chemistry following the JAMB syllabus. We will consider it according to the way they appear. Okay. Those syllables needed. Let me share this to the group. All right. So remember to drop your questions also as I move on. But let's connect with those people that might likely join. Okay, we are back. So looking at the screen, I'll be handling this kinetic theory, but we're going to start from the gas laws, looking at the B part of it. The laws: Boyle's law, Charles' law, Avogadro's, Gay-Lussac's, Graham Dalton's law of partial pressure, and molar volume. So these are the things that we might likely handle, but we'll start from somewhere anyway. So remember that you are on with the Majestic tutorials, your free school within school and after school, and your complete online school. All right, if you're live, you can send in your question on the comment section so we can hear you. Then if you have questions that you might not type well, you can send it to dailysciencequiz4@gmail.com. all right, so that's where you can send in your questions. So we start from the laws I just mentioned. Well, here we lift our notes, allow it to load. All right, so gas laws. Take this here and bring it here. Let's follow it the way JAMB wants it, in the correct order. Okay, you that is alive, you're welcome. Thank you. So we are looking at if you send in a message, I'll see it live and direct. I said where you can send in your question is send it to this mail: dailysciencequiz4@gmail.com. Of course, when you send it there, I'll receive the question and you will see it here live on the screen. So we'll be looking at gas laws, like I said today. Looking at what is here first, we say Boyle's law first. What do Boyle's law state? We will state and solve question with it, and it will be better if you come up with any question. So looking at this, Boyle's law, of course, states that the volume of a given mass of a gas is inversely proportional to its pressure provided that the temperature remains constant, or you say at constant temperature. This is Boyle's law for you. It might appear so simple, but it is not really as simple as, but it is very simple something. If you listen well, you will understand how to do it. This implies that what property is varying is volume versus pressure, and constant temperature, and it says inverse. This is sign of proportionality and this is inverse, 1 over. Therefore, to remove sign of proportionality, we have that V equal to K over P, such that K, which is constant, equal to PV. This implies that anytime you multiply pressure and volume, that you get a constant. Pressure and volume of a given mass of a gas will always give you a constant figure. In that case, it implies that P1 V1 equal to P2 V2. So use a diagram to explain this so that you understand the law very well. Even though your wordings might be correct, as in this wordings you state, what you say during the law might be very correct, but most people don't really understand what the law is saying. To make this clearer for us, the obvious thing there is this. If they are telling us that whenever we have volume at its highest, pressure is at its lowest. When volume starts decreasing, pressure will start increasing. That is inverse proportion. As we move on, V becomes bigger and V becomes smaller, and P becomes bigger. Just like you and your friend, let's assume at the point you are the richest, that's when your friend is poorest. Let's assume. It means that two of you are inversely proportional. And why do we say that it is a constant? That let's take this one as this is V1, V2, P1, P2. Now, what is the constant there? Do you know that from here to here is equal in length? Even though V is very big here and P is very small. But anytime you multiply the product of V and P, it will give you the same thing as V2 and P2. It's the same length from here to here. Is equal to from here to here. But the individual sizes, V here is smaller than V here, while P here is smaller than P here. So in the other way around, we are seeing inverse proportion, but what matters is that the length from here to here is constant. But when you come to V2, look at the position it occupies. When you come to V1, look at. But whenever you sum from here and from here, it will give you what? A constant. So this is telling us that anytime we multiply, if the first pressure was 5 atm times maybe the volume was 4 dm cube, anytime the pressure changes to 10, volume must reduce to 2, such that 5 times 4 will be equal to 10 times 2. 5 times 4 is 20, and 10 times 2 is also 20. So the individual values of pressure and volume will change, but the final product of them will never change. So that is what we mean by this Boyle's law. Now, graphical representation of Boyle's law, there are two good ways we should represent it graphically. So let's look at graphical representation of Boyle's law. All right, looking at this, we will have the axis for temperature, the axis for pressure, the axis for volume. So looking at here, so here is our V and here is our P. Anytime pressure is plotted against a volume is plotted against pressure or pressure against volume, either way around, it gives this curve. This is Boyle's law. Secret is that when you look at both axes and you did not see temperature, look at volume, look at pressure, you talk of Boyle's law. In other words, T is equal to what? Constant. One way of representing Boyle's law. We can also represent Boyle's law graphically by this. Right? So if we look at this, our volume remains V here and this is P. but it will give us the same. But let's assume we are plotting inverse, volume over inverse of pressure, or pressure over inverse of volume against inverse of volume. It will give us now a positive line graph. So you have to be careful to know that these two graphs correctly represents Boyle's law. All right. Now we take example calculations involving Boyle's law. Remember that Boyle's law is telling us that volume and pressure behaves opposite. Just like when pressure stands up, volume sits down. When volume sits down, pressure stands up. In a direct proportion, it is not what is obtained here. Direct proportion is that when one is going up, the other one is also going up. But inverse proportion is holding that when one goes up, one will go down. That is inverse proportion. It simply means when your expenditure goes high, your savings goes low. But when your expenditure goes low, your savings goes high. That is the simple thing that will make you understand that. So we look at some calculations. We'll take one example, then if you bring one, we'll go. They can ask us if 300 cm cube of a gas exerts a pressure of 600 millimeter mercury, calculates the pressure of the gas. Remember, if you are live, you can bring in your question. I'll see it here. 600 millimeter mercury. Calculates the pressure of the gas if the volume decreases to 200 cm cube. Now, we have to know units for measuring, because in exam, nobody will tell you the law to use. But the secret is that sometimes they will say at constant what? Temperature. If you hear at constant temperature, you use Boyle's law. And Boyle's law formula that we use for calculation is this: P1 V1 equal to P2 V2. Now, in the exam, nobody is telling you this calculation should be solved using Boyle's law, or that this calculation should be solved using Charles' law. No, nobody says that. It is you that will know which law to apply. How do you know it? By mastering the units. Millimeter mercury is for pressure, cm cube and dm cube is for volume. Now, we have to learn some units to help us identify when we are to use Boyle's law equation or Charles' law equation. How do we know that? The units in the question, we have volume here, we have pressure. Even though this question says pressure. But what if you meet question that did not say pressure and just gave you units? So what are the units for measuring pressure? The common units for measuring pressure includes millimeter mercury. We also have centimeter mercury. Then we have Newton per meter square. Then we also have ATM. So one should be able to convert from one to the other among these four. We can also measure pressure in pascals. But in chemistry, these are the common ones that appears: millimeter mercury, Newton per meter square, and ATM. ATM means atmospheres. Atmospheres. So in this case, what you have to learn is that anytime you hear millimeter mercury, they are talking about pressure. If you hear about Newton per meter square, it is talking about pressure. If you hear ATM, which means atmosphere, it is talking about pressure also. Now, the conversions are also necessary before we solve this question. How do we convert? We convert by 1.0 ATM is equal to 760 millimeter mercury, which is equal to 76 centimeter mercury, which is also equal to 101,325 Newton per meter square. So these are the units that you must master for conversions. Remember not to solve in different units. pressure must be in the same unit. P1 must be in the same unit with P2. V1 must be in the same unit with V2. Don't solve while pressure is in different units. You have to convert to the same unit. That's the need of this you are seeing on the screen. And this will also help you to know when Boyle's law or Charles' law is being applied. Now, looking at these conversions, provided you have mastered it, sometimes they can put this in a standard form. All right, sometimes we can get this equation in a standard form. So the way you join in the standard form is just like this one. I mean 1.01 times 10 raised to power 1, 2, 3, 4. Most times you say raised to power 4. Or if you started here 1, 2, 3, 4, 5, yes, raised to power 5. So it's still the same thing if you see it in a standard form. Okay. Now, just a minute, let me send a link. All right, we are back. So looking at this question, if 300 cm3 of a gas exerts a pressure of 600 millimeter mercury, calculate the pressure of the gas if the volume decreases to 200 cm3 at constant temperature. You write solution as usual. But in exam, after teaching you how to calculate, if you follow my past live stream, you know how to answer this without even calculations. So you already know that this is Boyle's law. You use P1 V1 equal to P2 V2. We are looking for P2 anyway. So P2 make subject of the formula is equal to P1 V1 all over V2. Then our first pressure mentioned was 600 millimeter mercury. Our V1 is 300. Therefore, P2 is equal to 600 times 300 divided by 200. That is the second volume mentioned. So you can cancel out, so that we have 600 by 3 should be 1800 if I'm not mistaken. Or we can continue. This is 1, and over here is 300. So 300 by 3 is 900. So we will have 900 millimeter mercury should be the answer, right? If you check this, does it conform with the law? Yes, it does, because our P1 was 600 millimeter mercury. Our V1 was 300 cm3. Then we finally calculated and got our P2 as 900 millimeter mercury. And then V2 was 200 cm3. Remember what the law says, that when volume increases, pressure will decrease. Now look at pressure and vice versa. Pressure was 600 and it became now, okay, let's give the question 300 from 200. It means volume decreased, which implies that P2 must be more than 600. Why? Because volume decreased. That's the inverse proportion. So decrease in volume directly means increase in pressure for Boyle's law. And with this, you can guess the answer without having to calculate, which means that if I have, let me set a new parameter. Maybe in another question, you see that P1 was 780 millimeter mercury and V1 happened to be maybe 380 cm3. Then P2 was given to you as maybe 970 millimeter mercury. Do you know that V2 you can suggest it? Why? Watch this. 780 became 970, which means there is increase, pressure increased. And when pressure increases, it automatically implies that volume must decrease. Therefore, V2 must be less than 380. So if you look at the option and there is only one option that is less than 380, you answer it and go your way. All right. So this is it for Boyle's law. We go to the next. It says Charles' law. Following the JAMB syllabus. Remember, this live stream is following the JAMB syllabus. Charles' law is the next we will consider. Charles' law states that the volume of a given mass of a gas is directly proportional to its Kelvin temperature. Be careful here, to its Kelvin temperature. The temperature must be in Kelvin. Only in one constant. So this law looks similar to Boyle's law, but the difference is that this law is and what? Temperature this time around. While Boyle's law compares volume and pressure at constant temperature, this one is comparing volume and temperature at constant pressure. Demonstration of this, example of where Charles' law is demonstrated is expansion of balloon that is placed under the sun. If balloon is filled with air tied to an extent like this and placed the sun will heat it, that is increase in temperature. After some time, the size of this balloon will do what? Increase or eventually burst. Why? Because we have increased the what? You have increased the volume have to increase. So expansion of gases when heated is a pure demonstration of Charles' law. The higher the temperature, the higher the volume. And that is what we call direct proportion. If I tell you, why are you not reading your book? And you now tell me, what is your business? That is direct proportion conversation. I say, are you talking to me? You say, why won't I talk to you? In that case, we call it direct proportion, because the response, as the other one becomes more arrogant, the other one becomes also more arrogant. But in a discussion between a trained child and a responsible father also, if they tell you, come here, why don't you go to school? Say, oh, sorry, dad, you're already afraid. That's inverse reaction. So here, if temperature is high, volume is high. That is Charles' law for you. So expansion of balloon placed under the sun demonstrates or illustrates Charles' law. Let us look at the graphical representation of Charles' law. And then we'll look at the equation. Graphical representation of Charles' law. Here we have volume versus temperature now. Please, temperature in degrees Celsius, volume in cm. Whenever this graph is plotted for Charles' law, it gives us a positive line graph. Remember not to confuse this graph with Boyle's law. You can have Boyle's law like this, but the difference is that this is volume and this is temperature. Volume, temperature, it is showing Charles. If you see temperature, see it. That's Charles' law now. But when you see pressure, either place, pressure and volume, Boyle's law. Then look at this graph. You see? This looks more to the Charles' law, but the difference is that this is 1 over inverse of P. It is the same thing that is obtained when you plot pressure over inverse of volume. You still have a straight line graph. But when you plot pressure and volume for Boyle's law, you get it. No, you can't get this. What you will get is this. So this is the correct curve here. So master these things, because the JAMB will give you graphs and say which of the following graphs represents Boyle's law or the one that represents Charles' law. So this is one way of representing Charles' law. Another way of representing Charles' law graphically is this. our labeling here should be T in degrees, V in cm cube. Then over here is 0 degrees, and we have my degrees. There will be some graph like this, and then when traced, well, you have the tracing that touches. This is also Charles' law. Charles' law. Now, what will you understand? The volume of a gas will be 0 at what temperature? The volume of a gas, according to Charles' law, the volume of a gas, according to Charles' law, is 0 at what temperature? At what temperature will the volume of a gas be 0? Simple. Look at this graph. You don't need to solve anything. This is what the graph is all about. You trace it. This is at minus 273 degrees and not Kelvin, please. If you say Kelvin, you're wrong. Minus 273, this is practically obtained from plotting. At minus 273 degrees, the volume of a given mass of a gas will be 0 because it touches that line here. When it hangs, when you trace it, at that point of the graph, if the plotting was on a scale, is automatically going to be what? It's automatically going to be minus 273, practically obtained. All right? So we move on, and again, you now understand why 0 degrees is equal to 273. Why is 0 degrees equal to 273? The reason is very simple. Remember, for us to move from here to here, we will add 273 because that's the journey from here to here is 273. So when you say minus 273 plus 273, that is automatically 0 degrees, which mathematically shows that 273 Kelvin is equal to 0 degrees. So remember, while dealing on calculations involving gas laws, I repeat, whether Boyle's law or Charles' law, ensure that your temperature must be in Kelvin. All right? That's a fact. We are done with the graphical representation. So we are good to move to see the what? The mathematical expression of Charles' law. Remember, you are still on with the majestic tutorials. Your free school within school, and after school, your complete online school.
The majestic periodic table is here to rescue chemistry students everywhere. Struggling with the periodic table in classrooms, lecture halls, or laboratories? Worry no more. The majestic periodic table has arrived to solve 90% of the confusion students face. This masterpiece behind me is not just a chart, it is also a summarized chemistry textbook packaged into one powerful table. Every element box contains at least 9 key facts, beautifully organized and easy to understand. And yes, it covers the electronic configuration of all 118 elements. The colorful design highlights important trends at a glance, making memorization almost fun. Yes, chemistry can be fun sometimes. It also teaches the basic rules and laws that govern how are arranged into groups and periods. So students no longer have to cram what they can simply see with their eyes. Now, here's the exciting part. You can customize your own copy with your name, your school or institution, a friend or loved one's name. Perfect for gifts. It comes in different sizes, different materials, and we deliver anywhere exactly how you want it. The most informative periodic table ever made is finally here. Get yours today and make chemistry bow for you.
First, watch this advert. Buy from me, I equip laboratory, standard laboratory. I give you trusted reagents because my scientists equally medical equipment. Thank you. Your patronage is needed.
Looking for experts in building and equipping standard science laboratories? Need reliable surgical or hospital equipment? Easy World Science and Surgical Supplies Limited is your best choice for quality and excellence. We provide professional construction of standard science laboratories, high-quality laboratory equipment and reagents, durable surgical and hospital equipment, timely delivery of exactly the quality you request, expert guidance to assist you with any experiment or equipment usage. The scientific stay safe. Choose equipment and reagents that guarantee results and protect your health. Contact Easy World Science and Surgical Supplies Limited today. Majestic, reliable, affordable. Thank you.
Guys, Samantha took away my fear I had in chemistry and biology. You have to join the Easy World. My name is Victor Modia, a student. Anywhere you are, you can join us, join the Easy World, be a subscriber. Bye. Thank you later. Whenever you reach for me, I'm gonna do all that.
All right, we are back here. Let's focus on the equation, mathematical representation of Charles law. So from the Charles law, we have volume still varying with the what? Volume varies with temperature this time around, but it is directly proportional according to the law. So this is the sign of proportionality. To remove it, we introduce equal to sign and k as constant. So this implies that v equal to kt. And whenever v is equal to kt, it implies that k should now be, make k the subject of the formula, divide both sides by t, divide both sides by t. T will cancel t, such that k now is equal to v over t. We have gotten our Charles law. It means that anytime you divide the volume of a given mass of a gas by its temperature, it will give you a constant, provided it's the same gas, the same mass, unchanging. So, as usual, this implies over T1 equal to V2 over T2, also equal to V3 over T3, and continues like that. All right? So this is the equation that we'll be using in solving questions involving Charles law. All right? Then the demonstration of Charles law, like this one I have here, is for Boyle's law. But if I should do the alternative for Charles law, I will have something like this. This time around, and then divide by okay. Now this is volume and temperature. So this one is, when I'm small, you are also small. When I'm big, you are also big. That is direct proportion. At this point, volume is small, temperature is also small. As volume, the size of the letter V increases, size of the letter T also increases. So it means the higher the volume, the higher the temperature, and the higher the temperature, the higher the volume. Okay, these are just like business partners. Whatever you profit, I profit. So this one should be our Charles law, and this is the Boyle's. Is inverse, but everything is working on the same way. Immediately I start decreasing, you also start decreasing. Now let's take question from, let me solve one question on Charles law. So maybe they say at constant pressure, calculations involving Charles law. at constant, immediately they say at constant pressure, they have given you already a clue that we are asking you question on Charles law. 250 cm cube of a gas, 250 cm cube of a gas was heated from 25 degrees Celsius to 38 degrees Celsius. Calculate the new volume of the gas. At constant pressure, 250 cm cube of a gas was heated from 25 degrees Celsius to 38 degrees Celsius. Calculate the new volume of the gas. So in this case, nobody tells you which law to use. Like I said when I was teaching you Boyle's law. So nobody tells you, please, you need to apply no. Immediately you see units for volume is cm cube or dm cube, and unit for temperature is degrees or Kelvin. Now, remember, you tell the examiner using what? Let's assume, but that's not for JAMB anyway. You don't need to write all this. Using Charles' law, in JAMB, we focus on your answer, which says V1 over T1 equal to V2 over what? T2. Remember to put your temperature in, your temperature must be in Kelvin. Then make subject of the formula before substituting. That should be WAEC standard anyway. Doesn't concern anybody here. So, but we are looking for V2s. Therefore, mathematically, it's always advised to make it subject of the formula so that you don't substitute wrongly. V2 now is equal to, you cross multiply, that's T2 times V1 all over T1, because it will be V2 times T1. So in this case, we go to the question and look up what is our T2. Our T2 is 38. Remember, it was heated from 25 to 30. So 25 is our T1. First temperature mentioned is your T1. While our T2 is 38 degrees, the second temperature mentioned. Are you with me? So in this case, remember to convert as usual. So my T2 is 38. But I won't use 38, rather I'll use 38 plus 273. To convert degrees to Kelvin, you add 273. Then to convert Kelvin to degrees, you minus 273. All right? Then 38 plus 273, we'll find the answer, times V1, the first volume mentioned is 250 over the T1 is 25 degrees, but I will not write 25, rather I will write 25 plus 273. So whatever this gives you is the final answer, but we can still solve. 38 plus 273, 38 plus 273 is 5017, then times 250, then divide by we should have a bracket here. Small calculator, always missing in some features. 125440, 125440 divided by 25 plus this 5 plus 3 is 8, 2 plus 9, 298 anyway. Should be 298. So divide by 298 gives you 420.94. So 420.94 should be our V2, 420.94. To check whether what we solved is correct, we will look at the trend in the question. 25 to 38, temperature increased. So if temperature increases, volume will also increase. And first volume was 250 and our V2 was 420, which we are likely correct. So if our V2 was less than 200, we are no more following the Charles law because it says it's directly proportional. All right. So we look up here. The next law, bring in your question or questions if you have. The next law says Avogadro's hypothesis. They just said Avogadro's and Gay-Lussac's. I think we have exhausted our time for this live stream, but it is a 45 minutes live stream. We have a few minutes, 10 minutes left. So let me use it and cover Avogadro's hypothesis. Okay. So we are moving to Avogadro's hypothesis, even though it's a law and is already a theory, but we still commonly call it hypothesis. So Amedio Avogadro, but all we know is Avogadro, but his full name is Amedio Avogadro. Avogadro's law, but we commonly refer to it as hypothesis. So Avogadro's law states that at constant temperature and pressure, or at the same temperature and pressure, at the same temperature and pressure, equal volume of gases, equal volumes of gases contains the same number of gas molecules. So equal volume of gases at the same temperature and pressure contain the same number of gas molecules. This implies that if we are equal in volume, our moles, our molecules are also equal, only if our temperature and our pressure remains the same. So Gay-Lussac's law and Avogadro's hypothesis go together collectively hand in hand. Okay, this question, they hardly ask question on this Avogadro's hypothesis, but to explain it, it simply means that let's assume 20 cm³ of oxygen were found to contain maybe 1.505 times 10 raised to power 23 molecules. Then 20 cm³ of your mess, sorry to say that, 20 cm³ of maybe another gas, hydrogen gas. If both oxygen gas and hydrogen gas have the same temperature and pressure, this particular hydrogen gas will also contain 1.505 times 10 raised to power 23. So it doesn't respect the nature of the gas. It is only sensitive to volume and temperature. So if our volume is the same and our temperature is the same, automatically the number of molecules in us must be the same. If beans, assumed, is a gas, rice is also a gas, and these beans and rice share the same temperature and pressure, what Avogadro's hypothesis is saying that 1 cup of beans must contain the same number of repeating units like 1 cup of rice, irrespective of their size. But remember, this is not really true, because like when we use real beans, but I'm using what you already know. So they are insisting, since they are 1 cup, that is equal volume, and they have the same temperature and pressure, the number of beans here will also be equal to number of rice here. So irrespective of the gas involved, as far as their volume is the same and the temperature is the same, the number of molecules they contain must be the same. Do you understand? Let's take a look at an example. I'll give example 1 in the calculation. Maybe we have that if 6.02 times 10 raised to power 22 this time around atoms of nitrogen was measured to be and maybe we take it as was measured to be 500 cm cube. Was measured to be 500 cm cube. The follow-up question will be, you might now see, calculate the volume occupied by calculate the volume occupied by 1.505 times 10 raised to power 23. Sorry, this is not atoms, please. This should be molecules, all right? Because we are talking about gas now, of nitrogen gas. Occupied by 1.505 times 10 raised to power 23 molecules. Please, these molecules. Molecules of carbon 4 oxide at the same temperature and pressure with nitrogen at the same temperature and pressure with nitrogen. I'll read the question again in case if I'm writing fast. If 6.02 times 10 raised to the power 23 molecules of nitrogen was measured to be 500 cm cube, calculate the volume occupied by 1.505 times 10 raised to the power 23 molecules of carbon 4 oxide at the same temperature and pressure with nitrogen. Some authority will tell you at STP, and this one will still repeat at STP. You are not going to use that STP value like 273 and 760. No. If you are giving this type of question, solution, this our live stream is meant to last 45 minutes. We are 48 minutes old. Listen up. Since they share the same temperature and pressure, 6.02 times 10 to the power 23 molecules of this gas have this volume. It also implies that 6.02 times 10 to the power 23 of this second gas will have the same volume since their temperature and pressure is the same. So we don't care whether it's nitrogen or carbon dioxide. Since their temperature is the same, the number of molecules they have will be the same and their volume will be the same. So since they have the same temperature and pressure, 6.02 times 10 to the power 23 of this CO2 will still measure what? 500. So simply, since they have the same temperature and pressure, 6.02 times 10 to the power 22 this time around, I'm not giving you Avogadros. Avogadros is raised to power 23. 6.02 times 10 to the power 22 molecules of CO2 will also have the volume as that of nitrogen because they share the same temperature. Now, your job is now to say 1.505 times 10 raised to the power 23 molecules CO2. We have what volume? X. You cross multiply such that at the end we have that X is equal to 500 times 1.505 times 10 raised to the power 23 divide by 6.02 times 10 raised to the power 22. Remember what to do to avoid your calculator from failing you. What you are going to do is just make sure you open brackets and open again. Then when you say 500 times, you are going to open bracket and close this. If you press this straightforward, you might get a wrong answer in exam. But when you keep following me on this live stream, because raised to power, you might not see it in the JAMB calculator, the CBT calculator, I'll tell you the cheats to use to solve this problem. So whatever you get here as X is the answer to that question. All right. Remember, you are still on with the Majestic Tutorials, your free school within school, and after school, and your complete online school. So bring in your questions if you are still live at daily science quiz 4 at gmail.com. All right. So what you are watching is our day one in the 2026 JAMB Chemistry Prep, demystifying the chemistry JAMB topics. We are following the syllabus as I displayed for you. So a week today, we shall also handle our questions as usual, past questions and their answers. Then you can equally book for your private coaching with Sa Majesty. These are the packages available. Your job is to chat me with this number here, 07065166217. If you're chatting outside Nigeria, you can put +234 to get your own intensive training on chemistry and biology. So these packages are available for you. Make sure you participate in any one. 4 periods per week. If what you are enjoying is helping you, why not come in and take more? Come in and take more. This package is for 6 persons in that will be joining live. I'll answer your questions. Remember, what are the benefits? Unlimited question and answer access. Anytime you ask question, I will answer you. If you subscribe to any of this package, you just contact me. Classes will be holding on Google Meet, WhatsApp, and YouTube live streams. Like this one. This one is free that I do every Friday for everyone. But people that participate in any of these packages will get it 4 times every week and unlimited past question. You will also be assessed weekly. The main aim is to score 370 and above. This package will favor medical students more because I'll handle chemistry and biology by myself, and you are assured of getting 90 and above in these 2 subjects. Imagine 90 plus 90 is 180. You can now, if you make it 60 in another one, you are already 300 and above. All right. So you are watching Majestic Tutorials, where top educators deliver simplified lessons across major art and science subjects, a true hub of expert teachers and impactful learning. As you can see, as you enjoy the class, do not forget to subscribe and share with others. Don't forget to subscribe and share with others. Next week, we'll continue with this package. We are heading towards 500 questions. We will also do this and continue our teaching. All right. And then, if you need your periodic table, we have it here.
Table is here to chemistry students everywhere. Struggling with the periodic table in classrooms, lecture halls, or laboratories? Worry no more. The Majestic periodic table has arrived to solve 90% of the confusion students face. This masterpiece behind me is not just a chart, it is also a summarized chemistry textbook packaged into one powerful table. Every element box contains at least 9 G facts, beautifully organized and easy to understand. And yes, it covers the electronic configuration of all 118 elements. The colorful design highlights important trends at a glance, making memorization almost fun. Yes, chemistry can be fun sometimes. It also teaches the basic rules and laws that govern how elements are arranged into groups and periods. So students no longer have to cram what they can simply see with their eyes. Now, here's the exciting part. You can customize your own copy with your name, your school or institution, a friend or loved one's name. Perfect for gifts. It comes in different sizes, different materials, and we deliver anywhere exactly how you want it. The most informative periodic table ever made is finally here. Get yours today and make chemistry bow for you.
Indeed, chemistry will bow for you if you do. Now, you see this, if you haven't subscribed, follow me across the social media handle. On WhatsApp is there. You can join our group on WhatsApp to know when this live stream will happen. I'll share the link there. Then on Facebook with Majestic Tutorials, and also on TikTok with the same name, Majestic Tutorials.
First, watch this advert. Buy from me, I equip laboratory, standard laboratory. I give you trusted reagent because I'm a scientist, equally medical equipment. Thank you. Your patronage is needed.
Looking for experts in building and equipping standard science laboratory? Need reliable surgical or hospital equipment? Easy World Science and Surgical Supplies Limited is your best choice for quality and excellence. We provide professional construction of standard science laboratories, high-quality laboratory equipment and reagents, durable surgical and hospital equipment, timely delivery of exactly the quality you request, expert guidance to assist you with any experiment of equipment usage, the scientific stay safe, choose equipment and reagents that guarantee results and protect your health. Contact Easy World Science and Surgical Supplies Limited today. Majestic, reliable, affordable. Thank you.
All right. Next should be in the next 5 minutes. We will continue with biology. Okay. So stay on. What this particular live stream is ending. It is nice having you. Then this is a question I received from one person on the mail last time, but I didn't see the person on today's live stream. So remember, you can send your questions where dailysciencequiz4@gmail.com. Send your questions there and join every Friday where the question will be attended to. I say where we can send in question is Daily Science Quiz 4 at gmail.com. So that's the mail for this channel. You send in your questions there and then come very early to this live stream. I will attend to your question. So this is question on solubility, but if I've received any comment from the person, I would have answered this question. So when you send in your question, you remember to come live. We start this live stream every Friday by 8 p.m. Nigerian time. That's GMT +1. It is nice having a wonderful person like you. Let's take a little break and come back for biology live stream. God bless you guys. Stay majestic. Bye for now.